first 4 or 5 minutes, right around in there, I want you guys to do question number 1. It says to draw an outline for a completely randomized design to compare the two treatments. If you remember yesterday, the very last part of the check your understanding question was drawing an outline. So use page 20 to help you do question number 1. I'm going to give you, like I said, 4 or 5 minutes to work on this piece, and then we'll go over it. No, I get it. No, you don't. No. Got like 2-3 minutes left to finish your outline.
Just like do some of my favorite challenges. It was the starting of the third classes.
All right, let's look at your outline and compare it to mine. So again, this is for a completely randomized design. What do you need to start off with? 50 students. And then what are we going to do with those 50 students? Randomly assign them to what? Groups of 25. Remember, we want our groups to be roughly equivalent. And then what do we do with those two groups? What should happen to group 1? Online. And group 2? Classroom, teacher prep. Sounds good. And then at the very end, what do we want to do? We want to compare SAT scores. Beautiful. Absolutely fantastic. Would this be enough if on the test it said, describe how you would set up a completely randomized experiment? No, this is an outline. This is like a skeleton for your description, so you make sure that you hit all the parts. But especially that random assignment part, you have to flesh that out a whole lot more. Talk about labeling the students and then using a random number generator to select 25 unique numbers, blah, 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 blah. So you'd have to go into a lot more detail about that random assignment part. Okay, let's look at question number 2. Of the 50 students that are signed up for the prep course, 30 are juniors and 20 are seniors. The counselors are worried that when we do this random assignment part, we could potentially put all of the seniors into one of these two groups. I could end up with 20 seniors and 5 juniors here in my online prep course. Or I could end up with all 20 seniors and 5 juniors in my teacher prep course. Would that be an issue? Why would it be a problem if all my seniors ended up in one class? They've taken more classes, so they've had more exposure to material that might be on the SAT. What would that mean could potentially happen here? They would have higher scores no matter which group they were in, right? So if we get the results of this experiment, this completely randomized experiment, if we get those results back and it's my group 1, my online prep course that has the higher scores, but it also had all of my seniors, I'm not going to know if that's because they were seniors or if it's because of the class, right? So that would be a problem. Seniors tend to score higher on the SAT. Why do you think seniors tend to score higher on the SAT? I mean, I know they've taken more classes. They've already taken it before. They took it as a junior, right? So not only do they have more classes, not only do they have more maturity, possibly more motivation, but they've also seen the test and sat through it once before, which in and of itself tends to improve scores. How could we adjust our experiment to eliminate this potential problem? Draw an outline of the experiment with your modifications. So, does the beginning of this change at all? No, I still have 50 students. Do I want to take all 50 of those students and randomly assign them? No, I'm worried that grade level, age, could be an issue here. What would we call that type of an issue that I think is also going to have an effect? I'm looking for a C word. A confounding variable. I'm afraid that grade level here could be a confounding variable that my randomization might not adequately take care of. There is a chance that I'm going to end up with a very senior-heavy course. All right, so what do I want to do with my 50 students then, since I'm worried about grade being an issue? Divide them into juniors and seniors. So 20 seniors and 30 juniors. Okay, then let's focus on just the seniors. What do I want to do with those 20 seniors now? Randomly assign them. Randomly assign them to what? Online or teacher-led in person, yes. But before I get around to online and teacher-led, what do I have to do in this random assignment part? Like, I'm just slowing our thinking down a little bit, yes. I need to make 2 groups of 10, yes. Are you okay if I call this one group 1S for senior? And I can call the other one group 2S. Group 2S, we want 10 in group 2S and 10 in group 1S. I could use A instead of S. Just remember that that's not a letter, it's not is, and it's not a 5. When I write really messy, my S's and my 5s look disturbingly similar. All right, so group 1S, what's going to happen with group 1S? Online sounds good. Online prep course. And group 2S then would be in classroom, my teacher led. All right, still just looking at my seniors. After they've taken either the online prep course or the teacher prep course, what do I want to do now? Compare their SAT scores. All right, let's go back and look at our juniors now. What's going to happen with my juniors? Random assignment. Into what? Into 2 groups of 15 each. What can I call these 2 groups? 1J and 2J. Group 1J, 15. Group 2J, 15. I hope those lines aren't confusing you guys too much. I cannot write straight for the life of me without lines. So I put lines in the background. Even if I'm not writing on them, it just helps keep my writing straight. All right, group 1J, what should happen to them? Online. And group 2J? Teacher-led, in-person classroom. Goodness. All right, they've taken their classes. Compare their SAT scores. Not done yet. I know now by analyzing my results, comparing those SAT scores, which class is better for my seniors. And I know which class is better for my juniors. But I might want to say which class is overall the better choice. Then I would need to take both of these two groups, combine them, and compare. Bless you. Get that up just a little bit higher on my screen there. This type of a design is called a randomized block design. This is a randomized block design. My blocks are my 20 seniors and my 30 juniors. Didn't we already talk about something where we take our group and we split it into smaller groups based on some criteria? What'd you say? Yeah, we did stratified random sampling, and then we called these strata. In a block design, these are not strata. It feels like it, but this is not the same thing as strata. Specifically because when we do strata for sampling, do we have everybody in one of those strata do something? No, we pick a couple people out of each of the strata that we've created. With a block design, I separate them into my two blocks, and then everybody in the top block is going to be assigned a treatment. Different treatments. Everybody in my other block is going to be assigned different treatments. So not the same thing as strata. Similar feeling, but I don't want you to get those two confused. Strata, we just pick a couple from each of my like groups, my homogeneous groups. So far, so good with block design? All right. What happens, though, even if I do this, whether I'm talking about my completely randomized design or my block design, if I end up with all of my top kids, the highest GPA in the online group, is that a problem? Counselors are worried that the random assignment, whether we're talking about random assignment for blocks or random assignment in my completely randomized design, could potentially put all of the super hardworking, high GPA students into one of the treatment groups. So they have a list of all 50 of the students and their GPA ranked from highest to lowest. How could they use that list to help them set up this experiment? Yes?
Number the students in order of their GPA.
Number the students in order of their GPA, okay? And then do what? I heard systematic. Do what systematically? The random assignment. How would we do a random assignment systematically? Tell me more.
You would start with a random number, and then you would pick a number and count from the first number you started with, the second number.
And then go from there. I like that. Is it possible that by doing that, I'm still going to end up with the majority of my high GPA kids in one group, depending on what that random number is, my system? When I loop back around, I might still end up with all of my top GPA kids in the same course. But I like where we're going with this. So We've got our kids numbered and in order. We want to do something randomly here. Divide them by 2. I like what you're thinking here. Let's talk for just a second. Let's pretend there's only 2 kids signed up for this course, right? And it's numbers 1 and 2 on my ranked list of GPA. If I only had 2 people, could I guarantee that they ended up in different groups? What could I possibly use to guarantee that these 2 people end up in different groups? Do I have to use a random number generator? Could I use a random number generator? Yeah, I'd have it pick out a number between 1 and 2. Is there any other type of chance device that I could use other than a random number generator here that might be faster or easier? Javen, were you doing something with your hand? We could flip a coin, right? If it's just 2 people, we could flip a coin. We could draw straws. We could write it on slips of paper and you draw it out of the hat, what you're going to get. We need some type of chance device, and then we're going to put them in 2 separate groups. Okay, but then I still have the issue of everybody else on this list. I want to make sure that the people ranked 2, 3, 4, 5, 6, 7, that they don't all end up in the same group. So I could take maybe the 3rd and 4th student on the list, pair them together, make them flip a coin. Could I do that for each of the kids here? Could I pair them up and flip a coin for each of those? Yes. All right, so let's write that down. So we're going to pair the top 2 students. Then the next top 2 students. And so on and so on. Ending up with how many pairs? 25 pairs. All right, so I've got my 25 pairs. Top 2, number 3 and number 4, number 5 and number 6, number 7 and number 8, all the way until we get to numbers 49 and 50 paired together. Again, they're ranked by GPA already. You guys okay if we go with the coin flip? It's just less to write down, and it works as a chance device here. Okay, so I flip my coin for each pair. Do you think it's important that I say for each pair? Yes, because otherwise I'm only going to assign 2 people and everybody else is sitting around like swinging their legs, not knowing what they're doing. For each pair, flip a coin. All right, now here's where it gets sticky, because I have to be super, super clear. Anybody should be able to pick this up and execute what I have written here. So I can't leave anything up to doubt whatsoever. For each pair, I flip a coin. What are the 2 possible outcomes from the coin flip? Heads or tails. So I have to talk about what happens if it lands on heads. I have to talk about what happens if it lands on tails. So if it lands on heads, what should happen? Ooh, I like that. Since we have a ranked list, we could say the student who is an odd number in the ranking gets assigned, or we could go with even. That's fine. But again, we're just looking at the 1 pair. If it lands on heads, the student with the odd number ranking We'll do what? We'll do online. Sounds good. Will be assigned to the online prep course. I'm not going to put a period there, though, because there's still something else that I have to say. Even-numbered person would do teacher-led then. And evenly numbered student is assigned to the teacher prep course. All right, before we write anything else, I want to stop here and talk about the stuff that I really like that has come out so far, and then we'll finish this up. Things that I really like. We talked about what happens to both people. Even though I'm flipping the coin once, I'm talking about what happens to both individuals. The other thing that I really like is that we were really clear about which student we're talking about. I'd want to be careful by saying the first student does this and the second student does that, because what do we mean by first and second? So we have to be very clear about who we're talking about. And since we don't have any information about them, I have to come up with a way of designating them. You can do it alphabetically. The student with the last name that falls earlier in the alphabet will do this. The other student will do that. Using odd and even rankings would be perfectly fine because we have this chance device. So it's okay that those numbers weren't randomly assigned to them, because my coin will randomly decide. All right, there's one other thing we got to do here. Say what happens with tails. If the coin lands on tails, what? You could say vice versa, or I might want to be just a little bit more and just say, you know, odd number goes to teacher-led and even number goes here, but I don't have to write out as many words. But you could get away with saying vice versa since you've written out so much detail about the first part. If the coin lands on tails, then the odd student does the teacher course. And the even student does the online course. All right, things you have to make sure when you are setting up an experiment, especially an experiment in this way. You got to talk about what happens to every person. Have we talked about what happens to every person? Yes, give me examples of where we did that. And so on, 25 pairs. Evenly numbered student, odd numbered student. There's one other thing that's super important in here that we did. What'd you say? We talked about heads and tails. We talked about what happens with heads and what happens with tails. So we've covered all possible outcomes for our chance device. There's one other thing that I'm looking at, one other phrase that we have up here so that I know we hit every single student. And it's this right here. For each pair. If I left that part off, then I would only be describing what happens to my first two kids. I've got all these pairs, I've got 25 pairs, but then I would only take 2 students and assign them. And everybody else is just sitting around going, I don't know what I'm doing. For each pair, or you could say repeat for all other pairs at the end. But somehow you have to talk about you're going to do this over and over and over and over and over until everybody has a group, has a class. This type of a design is called a matched pairs design. A matched pairs design is kind of like a block design, but how big are each of my blocks? 2. So I would have 25 blocks, and each block just has 2 people in it, and they each get assigned to a different treatment option. So far, so good? Awesome, let's flip this over. All right. So we have now covered 3 different types of experimental design. We have our completely randomized design. We have our block design and our matched pairs design. A block is a group of experimental units that are all similar in some way. They have some criteria that makes them alike. What do we mean by experimental units? Participants, yes. The things that are being experimented on. We call them experimental units because it's not always people. Like if we were doing quality testing on computers, then my experimental units would be each of those computers. But experimental units are the participants in this experiment. In my randomized block design, we separate the subjects into blocks. How many blocks can you have? Doesn't matter. You can have as many as you want or need. And then you randomly assign treatments within each block. For my matched pairs design, the subjects are paired first. We have blocks of size 2, and then they are randomly assigned to a treatment. The other possibility, and you guys brought this up yesterday, do you remember Mr. Wilcox and the beard oil? What was one of the recommendations for how to improve that experiment? Split his beard down the middle. So in that case, we would have each subject receiving 2 treatments. Mr. Wilcox would have 2 treatments. One side would get no beard oil, the other side would get beard oil. But the order of the treatments has to be randomized. Some other ones that I've heard of before that I thought are really good is like if construction workers, if we wanted to test out what's the best type of work boot for a construction worker, we could have them wear one pair of boots on one week and another pair of boots the next week. Or if we wanted to be real smooth and make sure that all of these boots were exposed to the exact same conditions, they could be assigned to wear one boot on one foot and the other boot on the other foot. Because then they're going to be exposed to the exact same conditions. Maybe one week the job is a lot harder, a lot more rigorous. But we would have to randomly assign which foot. And then we would probably, after a week, need to switch it so that we have a left foot and a right foot for both of these shoes. Take about 5 minutes. I want you guys to do the check your understanding at the bottom. You're going to draw me 2 outlines. And then in the third question, I want you to tell me why in this situation a block design might be better. Like I said, take about 5 minutes. Yes. Your completely randomized design should look something like this. 300 subjects, random assignment. Groups 1, 2, and 3 should each be about 100. Group 1 gets assigned to add 1. Group 2 gets assigned to add 2. Group 3 gets assigned to add 3. And then at the end, you compare the results. How could we do a block design? What's the first thing you would need to decide? What the blocks are. So in this kind of a situation, if we're talking about ads for a presidential candidate, what could I use for blocks? What do you think might potentially be a confounding variable that we would want to control for? We could do political party. We could do age groups. I like both of those. Is that the extent of what we could use for blocks? No. But in the interest of time, I'm going to go ahead and stop us right there. So you could do by political affiliation or you could do by age group. When I made my answer key for this, I went with age group as blocks. How many blocks do we want? 2, 3. We got to decide how many blocks we're going to set up. I set it up with 2 blocks, but we could easily do 3 blocks. What's the youngest user I would want to consider? 18. Or maybe, you know, if they checked a little box like I will be 18 by the time of the next election, because you're allowed to register to vote even if you're 17. You just have to be 18 by the time of the election. So we could include a couple 17-year-olds maybe, but definitely 18 and up. So like I said, I split mine by age group, older and younger. And then random assignment for each of those blocks. I called them groups 1A, 2A, 3A, and then 1B, 2B, 3B. They each get assigned a different ad. We compare effectiveness within the blocks, and then we combine and compare at the end. Why might a block design be preferable in this context? And I kind of gave a hint to this one already. What does it let me control for? Potential confounding variables. In this case, with the way I designed my blocks, I think age might be a confounding variable. For those of you that chose political party, that would absolutely be a confounding variable that could show up. The goal with doing this is to decrease the variability within the block, which would make it easier for us to determine which one is the most effective. I want you guys to look over here for just a moment. Imagine that I have my 2 groups and I make dot plots for each group. If my dot plots look like this and I put one dot plot on top of the other, is it going to be easy for me to compare which one is higher, which one's... What about if it was more like this and I have more than one on the same scatter plot, or dot plot, not scatter plot? If I had a group over here and a group right here and a group right here, because they're all clustered together tightly, it's going to be easier for me to make comparisons. So I want lower variability, not higher variability, because I want to see them all clustered. And doing this block design is going to reduce my variability. When is homework due? Tomorrow. As a reminder, because this does come up on the questions, experimental units are the participants. Factors are the explanatory variables. And an experiment can have more than one factor. And then the treatments are the individual things that would be assigned to those experimental units. Have a great rest of your day, guys. I will see you tomorrow.